Hello, everybody. It's a real pleasure and a privilege and honor to be here and share some of our work with you today. I'm here as the head of our lab and my PhD student, Victoria, who will take over after I've done a little introduction of what we do in the lab in general. So the lab or the research group looks at different scales of our interaction with the built environment around, I would say, 4 pillars, which are all related to, or 3 of them are strongly related to the human, and one of them is kind of an indirect aspect, which is the energy performance. And these are vitality in the broad sense of health and well-being in the buildings, emotion, so this is more our experience of the space, and comfort, which is making sure that we can do what we want to do in those spaces. And all 4 of them, or the 3 that I just mentioned, also very strongly relate to daylighting, which is a core topic in the lab and my favorite topic as well. We had some advertisement for daylighting earlier this morning, so I'll piggyback on that to continue in that subject. And so what we have been doing, for example, on the perceptual aspects, was to look at how people perceive a daylight pattern, the variability of them, and their composition, choreography, we can say, by, for example, looking at the exact same amount of aperture and looking at how people would react to them. And it looks like for the exact same amount of light, the fact that it is differently composed has a big effect on what people say. And so we went further into that and had a mix between psychological answers or subjective questionnaires and answers and physiological ones. And so by exposing about 75 people to these kind of scenes, we could see that again the irregularity was linked to a preference, but also that when we measured their heart rate variability, we could see when we look at the difference between being exposed to a daylit scene and being exposed to an artificially lit scene, which was considered as the baseline, there was a calming effect of looking at a daylit scene, which is not contradicting the interest of it. Literature shows that when we prefer something, it tends to calm us down. And to move this further into what really pertains more closely to design, we looked at patterns that exist in contemporary architecture and again looked at what, in this case, designers would say about these patterns. So another aspect is to link this to comfort, and rather than just looking at visual conditions linking to visual comfort or thermal conditions to thermal comfort, also look at the interactions between the two. So if you look at this beautiful rainbow panorama by Olafur Eliasson and you pay attention to your thermal condition, to your thermal perception, maybe you will experience a slight difference by seeing something of a different color. And this is exactly what we want to find out about, whether one could influence the other and therefore have implications on how we should go about the building environment. And so this is the kind of experiments we run, either trying to link color of light with temperature, so same temperature but we change the color. What do people say? How do people also physiologically respond by measuring their skin conductance, their heart rate variability, and also the light quantity and temperature, and mix that with performance tests and subjective questionnaires. So the subject of today's paper is the 3rd pillar, so to speak, so the broadly defined vitality, which has already gotten a lot of attention this morning through our 2 keynotes, and it is about our non-visual system, our biological clock, circadian rhythms, and the fact that several key factors of the lighting environment do impact how we will respond to it, especially through 2 different pathways. The phase shifting pathway that we have heard about a lot this morning already, so our circadian rhythms, and the so-called acute effects or direct effects, the most well-known being melatonin suppression due to light. But it has there are also other aspects that could pertain during the day, because the melatonin is only produced at night, which would relate to alertness, fatigue, and cognitive performance. And this is what the topic of the paper today is. Keeping in mind that this is a sluggish it's a sluggish system, and therefore it's about adaptation, history, pattern, and so on. And so if we try to translate this into architectural terms, if we take a Richard Meier house built in Miami and move it to Reykjavik for the sake of the exercise, we can see these two effects kind of joining forces, so to speak, with the pink being the accumulation of dose that you would want to be exposed to reach the sort of the light exposure target, whereas the yellow curve is an illustration of how much you don't want to disrupt your circadian phase, your circadian entrainment. And so therefore, the whole point, of course, with daylight, there is little chance to disrupt it too much, but it's to really look at those two effects together, and not surprisingly, on a winter day in Reykjavik, you will not achieve the dose that you should with this house. So one of my other students, Maria, developed over the last 5 years a bridging effort with neuroscientists and photobiologists, especially at the Harvard Medical School, with whom I was working when I was at MIT before. And the idea is to be able to talk or extract what are the at least hypotheses, but some of them have already been demonstrated in lab experiments by photobiologists, so that they could pertain also to our built environment, the design environment. And as we have already heard this morning, melanopsin as a photoreceptor is more sensitive to the blue region. The intensity plays a big role. The pattern plays a big role. The timing, of course, also, and this is for circadian aspects, and the adaptation. And so a lot of these human-driven aspects, we have pushed them further. I'm not going to talk about that here, but I'm happy to talk about that during the break, into making them actually usable in an architectural practice and in the design of indoor environments by really evaluating these human-based aspects, emotion, health, health in this small, narrow interpretation, and comfort, and I can show you more if you're interested. But in this presentation and paper, we would like to focus on those two findings from photobiology, and Victoria, as well as Forrest Webler, who is not here today, have been looking at those two sort of statements or findings from photobiologists. And now what Victoria is going to present to you is her experiment to try to extract objective findings about these two effects, and the focus of that study was daylit workspaces. Why daylit? Because it's a way for us to still connect to the dynamic environment in which we evolved with, but these are also realistic indoor conditions. And the idea is to look at the impact of spectrum and brightness, one and the other, on psychophysiology of occupants, and therefore to look at the relationship between the non-visual and the visual system. So basically the questions that she's trying to address is, if you have the same visual response, meaning the same photopic illuminance, may red impoverished daylight, you can never add daylight with a glazing, you can only remove some of the color, so this would be not blue enriched but red impoverished. Would it be more effective? And on the other hand, with the same light spectrum, would bright daylight, or light in general, be more effective than dim? And these are the research questions that Victoria is going to talk about for her paper.
Okay, so I'm jumping in here. So I'm going to present briefly a field study we conducted in Lausanne at the EPFL campus. We selected these two classrooms, which are adjacent spaces, with the same south orientation, same layout, same characteristics, same everything, and with a particular characteristic, which is that they are both equipped with electrochromic glazing, electrochromic technologies. So to conduct this study, we selected a group of 35 participants, carefully looking at specific characteristics such as chronotype, sleep quality, overall health, personality, and so on, because we wanted to include only healthy participants. And we ended up with these two groups, a control group and an intervention group, that were randomly assigned and divided between the two classrooms. And so we equipped our participants individually with a series of light sensors. So we randomly assigned them with this fancy pair of glasses that included a small spectrometer that was recording continuously full spectrum and vertical luminance, or this other fancy headband with a capture that was measuring RGB only, so not full spectrum, and vertical luminance as well. And on top of that, we provided them with a small pin that was measuring as well RGB and illuminance. But we also wanted to tackle physiological assessments, so we provided them with, on the left, a heart rate monitoring device and some eye buttons to assess for the circadian aspects of the study that I'm not dealing with, but my colleague is. And so this is basically the structure that we were following for our experiment. We had these 4 steps timeline divided into 4 weeks. So we actually divided our experiment into 2 smaller experiments. So during week 1 and week 3, we provide our participants with all this equipment that I just showed you, and we basically ask them to wear it on a daily basis during their normal, following their normal activities, their normal life for 3 days, basically to record baseline data, both physiological and environmental data related with their light exposure. And during week 2 and 4 of the procedure, we conducted the actual experiments. Again, they lasted 3 days each, and the idea was to test, during the first one, the effect of spectrum only on our participants, and in the second part, we will test the effect of intensity only. So, the protocol that we were following during this 3 days experiment in this classrooms at EPFL was that we asked participants to come around 8:30 to the campus, and they were in situ randomly assigned to one classroom or the other. And what we basically asked them to do was to sit on the classroom from 9 a.m. to 4 p.m. and they were asked to do a series of tasks on an hourly basis, which included first a reaction time task, which lasted 3 minutes, and then a self-reported questionnaire to assess various factors. And then they will have these 45 minutes of individual work where they were somehow isolated in their own mind, let's say, because they were not allowed to eat or drink other than water or to interact with each other. So they were either writing, reading, whatever they wanted, but the only condition was to not to work with screen devices. So only paper or, yeah. And so they, every day during these 3 days of experiment, they had a 1 hour break for lunch where they were allowed to interact with each other, but they were not allowed to leave the classroom. And then we repeated the same procedure for the afternoon with, again, these hourly tasks repeated every hour. And then at 4 p.m. they were allowed to leave and go home, but still wearing all the devices. So for the tasks that they were required to do, we provided them with a smartphone that they were bringing to the classroom. And so the first task, the reaction time, was a psychomotor vigilance test that they were doing on the smartphone, followed by a brief self-reported questionnaire in order to assess 3 different concepts, such as alertness, fatigue, and affective state. And we also included some sleep and activity diaries that were replied by the participants in the morning, right after awake, and in the evening, actually, before going to bed. This is related with the circadian activity, but just for you to know. And so these were the research scenarios they were working on. So these are the 2 classrooms. On the left-hand side, we have the red impoverished environment. So we were using the electrochromic technology in here. It was on at a certain level of tint. The other classroom had the same electrochromic but off. It was not working. So what we did to maintain the same illuminance level in both classrooms, because what we wanted to see was the effect of a spectrum, so red impoverished against neutral, was to use some neutral filters to try to maintain the same levels. We also equipped the classroom with some other monitoring devices to record and map luminance, horizontal illuminance, and irradiance. And here you can see an example of the data that some of these individual light sensors were recording. So A is a random sample of one of the participants working in the classroom A, and B is a random participant again in classroom B, so you can clearly see the effect of the red impoverished lighting conditions in A against lighting conditions, neutral lighting conditions in B. So some results. We have these 3 different concepts that we were assessing: alertness, affective state, and fatigue. So these are some results for the vigor, which is a mixture between a way to assess fatigue and alertness all together. And what we can see is something interesting. When they arrive in the classroom at 9 a.m., they are so in gray we have results. These are the mean values for the 3 days combined on an hourly basis. In gray we have results from classroom A, which is neutral conditions. In blue, results from classroom B, red impoverished. So 9 a.m. they are both scoring more or less the same, which is good because this means they were not biased by the previous light exposure. Then I'm jumping into the lunchtime because we can see that there is like a change compared with the 2 hours before where they were working alone individually, and in the lunchtime they were allowed to interact with each other, and we can see an increase of scores. This is something that we will like to explore further. And if we go to the end of the experiment, again we can see a change on the mean values, an increase, so better results. And again, they were at this point allowed to interact again with each other. And if we look at the specific time that they were spending in the classroom working on their individual tasks, we can see a significant difference between scores on classroom under red impoverished and classroom with neutral conditions, having, and what we can see is much higher scores under red impoverished conditions. If we look at the affective state, which is somehow related with our mood, what we see is very flat results. Unfortunately, not significant results in this case. But if we jump to our main interest, which is alertness or sleepiness, in this case the Karolinska sleepiness scale, we see again the same trends happening as we saw in the first scale when we were assessing fatigue and alertness together. So at the beginning of the day, scores almost the same. They are not, in theory, biased by the previous light exposure. During lunchtime, we see a significant drop. It's important to highlight here that smaller bars means that they were more alert, higher bars means that they were more sleepy, so the higher the worse, and the smaller the better. And again, a significant drop at the end of the day compared with the previous 2 hours of individual work. So again, we obtain significant results for the periods of time where these participants were individually working, not interacting with each other, and staying in these 2 very different classrooms. And again, much better results. People were feeling much more alert in the red impoverished classroom compared with the neutral one. It was also interesting for me to show that if we look at these results on a daily basis instead of the global results, we see that during day 1, results are not flat, but the changes between, the difference between the higher and the lower values is small, let's say. But if we move to day 2, we can see that the difference is much higher than in the previous day. And if we look at the 3rd day of experiment, the difference between this and the first day is significantly different. So one of the outcomes that we learn from this experiment is that duration of exposure indeed plays a key role when assessing acute effects, mainly due to our adaptation to new lighting conditions. Second outcome that we learn is that daylight is indeed a powerful stimulus. Even as in this case, even when they are under very dim conditions, as they were in this case. I show in one of the previous slides that they were always being exposed to lighting conditions below 50 luxes. So it was really hard and difficult to work in there, but still the results are quite significant when we compare one to the other. And finally, that the red impoverished condition is more effective than the neutral one when assessing this kind of acute effects. But we still have some next steps to follow in the upcoming months, which is to analyze the objective and the physiological data. So the reaction time tasks, which will provide us with much more objective overview of what people were actually experiencing, and the heart rate variability data, or the physiological marker that we are using. And the final aim or the final goal will be to compare and merge all these 3 blocks of subjective, objective, and physiological data and see what we can understand and learn of this very fundamental analysis of the influence of the spectrum of daylight during daytime in real scenarios. And that's it.
Thank you very much.
We have time for one question. Any questions from the audience? If not, thank you very much. Oh, yes, we did.
Did I misunderstand, but the first endpoint seemed to favor one treatment, and then the sleep? The first endpoint seemed to favor the one treatment, and then the sleepiness would favor the other. Did I misunderstand it?
There was a change in scale, so to speak. The first one was vigor, so the higher the better. Mm-hmm. The second one was sleepiness, the lower the better. So this is the opposite of alertness. Okay. So they were both saying the same thing.
Yeah, exactly.
very much. I think we